Good afternoon, guys. We're going to talk about some properties of equality today. So we're doing algebraic properties. These are the properties that we've been working with since probably elementary school, but we're going to give them some formal names and definitions so we can use them as we work with proofs in geometry. And basically what we're saying here is whatever operation I do to one side, I'm going to do to the other side of the equation. And our addition property of equality, this is usually how I abbreviate it because I'm a lazy writer, says that if I have A equal B, then I can add something to one side as long as I add it to the other side. So I just added C to both sides. Same idea for subtraction. I start with A equals B. So if I subtract a number from one side, I just have to subtract it from the other side. Multiplication and division are the same. So if I start with A equals B, then whatever I multiply to one side, I have to multiply to the other side. And whatever I divide from one side, I have to divide from the other side. And our substitution property says that if A equals B, then I can substitute, this is our substitution property, A for B, or I can substitute B for A. So for example, you might have seen in Algebra 1 something like 3x plus 9 when x equals 7. So what you would have done to simplify this is substitute in a number for x because x equals 7. You're given that. So if A equals B, I can substitute A for B, or I can substitute B for A. Well, let's identify some of these properties. You're just going to check out what changed or what's new in each line. So I filled out some of the simplifying lines. I just want you to focus on the ones with our algebraic properties of equality. So look at lines 1 to 2. What changed from 1 to 2? Well, I put in red that I added 9 to both sides. So this would just be my addition property of equality. And then, of course, I simplified everything up. And in step 4, what changed from 3 to 4? So from 3 to 4, what's new? Or what step did I take? Well, I divided 7 from both sides. So that would be my division property of equality. You're just identifying what operation do you see. I'd like you to pause the video in number 2 on the right and see if you can fill out those last 2 lines. So you should have unpaused. Your work should be done now. You start with a given statement always, and then what did I do to each side? Well, I multiplied by 5, so that must be my multiplication property of equality. And here, from line 3 to line 4, what changed was I divided by 12 on both sides. So that would be my division property of equality. You're just identifying what is changing here. What step am I taking? Let's try another set. So look at what's going on in the red. Pause the video and see if you can fill out these next steps. So you should have unpaused. You should be done now. I've got 2x minus 2. So from line 2 to line 3, what changed is I threw in a minus 2 on both sides, or minus 2x rather. So this, if I'm subtracting, would be my subtraction. property of equality, because what I did to one side, I also did to the other. Same idea over here. I went from 1 equals 3x plus 4, and then I just subtracted 4 from both sides, so that'll be subtraction property of equality. In my last blank here that I need to fill in, I start with negative 3 equals 3x, and then it looks like I divide by 3 on both sides. So that will be my division property of equality. And then we just have the distributive property, which you guys know, you've been working with it forever. If you have a number outside of some parentheses, you just distribute that to both parts. And then be careful about your negatives. Make sure that a positive times a negative is a negative, and a negative times a negative gets you a positive. And let's talk about the other properties. Maybe I should put those in quotes. Those are the non-algebraic properties, those properties that aren't your algebraic operations. These are your reflexive, symmetric, and transitive properties of equality. And your reflexive property just says that something is equal to itself. Whatever that thing is, it could be a number, could be an angle or a distance, but something is equal to itself. So A equals A, 5 equals 5, 29 degrees equals 29 degrees, measure of angle A equals measure of angle A. And the reflexive property, what you'll notice is that it's the same exact thing on both sides. So exactly what you see on the left side is the same as what you would see on the right. People always get the symmetric and reflexive properties mixed up, and I understand why. But what you should be looking for is, did I switch the order? Because your symmetric property switches the order. And if you're thinking of, and the transitive property is a lot like your law of syllogism. If you remember the law of syllogism from our conditional statements chapter, that's what the word is. If you remember a law of syllogism, it was something like, if it's raining, then practice is canceled. If practice is canceled, then I can go to the mall. So, if it's raining, then I can go to the mall. You're connecting several pieces of information into one. Same idea with the transitive property. If A equals B and B equals C, then A equals C. Or if X equals Y and Y equals 2, well then what does Y equal? Well then Y would have to be equal to, X would have to be equal to 2. You're doing the same thing. You're still connecting several ideas into one. But we call this the transitive property when we do it with algebra. So let's look at not 1 and 2, A and B. Examples A and B. And always check, did I switch the order? Did I use the symmetric property? So look for, did I switch the order? A, if M equals 6, if measure of angle 6 equals the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. I switched the order. It was 6 then 7. I switched it to be 7 then 6. So if I switched the order, that must be the symmetric property. And B, 34 equals 34. A equals A, AB equals AB, 7 equals 7. If it's Monday, then it's Monday. I'm taking one thing and setting it equal to itself. So this has got to be my reflexive property. I didn't switch the order. I really couldn't switch the order because there's just one term. And our last one here, if 1 equals 2 and 2 equals 5, then 1 equals 5. I'm connecting a bunch of different ideas. This is my law of syllogism. This is the transitive property. I'm going to give you guys a second. See if you can identify the properties here. Remember, reflexive does not switch the order. Symmetric does. So pause the video, see if you can get these, and then unpause, check your work. Number 1, I don't switch the order. That's reflexive. Number 2, you can see it was 5x plus 1, then I switched it to be 1 plus 5x. Must be symmetric. There's my line symmetry. And 3, if a equals b and b equals c, then a equals c. This is transitive. Oh, and we have one more. A equals b, measure of angle A plus measure of angle B equals measure of angle B plus measure of angle A. I switched the order, so that must be symmetric. Check your homework. Come in for office hours, either online or in person, and I will see you guys in class.